So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna talk about a crazy paradox. Okay, we cannot understand that without looking at that. So, firstly, let's just take a look at that. This is this is it what we are gonna deal with in this video today. Whoa, you know what? Uh, One of my subscribers just commented me a lot of times that he wants videos on Riemann hypothesis, right? Riemann hypothesis. Okay, so I would say if you are watching this video, so I'm just in work of that, so I'm just working on over that. So I would say just be patient and yeah, basically this video is going to be the first video, or this is not basically it's not totally depending on the Riemann hypothesis, I would say, but yeah, if like in some upcoming videos, if I'm just gonna bring the Riemann hypothesis video, so I'm gonna use this result to just blow your mind again. Okay, well, yeah, so now let's just consider this equation. First of all, I would just like to do something here, and that is I would like to just erase this thing, I would say, because the result is itself something crazy, I would say, because that doesn't make any sense at all. Now let's just consider this equation. So this is basically Ramanujan's paradox. Okay, yeah, it's not I would say this is subjective actually, whether you like whether you accept this equation or not. It's subjective. Okay, now let's just take a look at this thing. So it's 1 plus 2 plus 3 plus 4 plus 5 plus n and plus dot 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 to infinity. Okay, so basically it is, basically we can say it's sum of all natural numbers. Obviously it is including from 1 to infinity. So sum of all natural numbers evaluates to, you know what, this result. Oh, wait a sec. Yeah, this crazy result, that is negative 1 over 12. Well, first of all, I know if you haven't seen this before in your life, so you're gonna just say, what the hell you are saying, man? So I would say, please believe me, I'm gonna prove this in this video, so you just have to be patient. And you know what the crazy part is? Like, have you ever added some natural numbers? Obviously you did. So let's say we are adding 1 plus 2 plus 3 plus 4 plus I'm sorry, it's plus 4 plus 5. What are we gonna get? So it's 5 plus 4 9, 3 12, and 3 15, right? And it is also a natural number, right? And it's not a, I would say it's not in fraction, it's not in fraction. And when you add up when you add up some natural numbers till n, so you're gonna have a positive natural number as the result, right? But if we talk about this infinity, well, the when n is tending to infinity, so it comes out to be negative 1 over 12. Does that make any sense? In our general life, everyone would say, Aman, this is not true, and I would say, ah, you're right. But now let's just talk about the proof of this. Okay, so basically, how did Ramanujan prove this? Let's just talk about that. Okay, so basically he using Grandi series. Okay, I hope you don't you are not familiar with this. I'm sorry about that. You might not know about this, but yeah, let me just tell you that. So let's say that let s1 equals 1 minus 1 plus 1 minus 1 plus 1 minus dot 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 to infinity. So this is an infinite sum, I would say, because alternative plus like alternative signs of 1 like is being added to this sum. Now you would say, what's problem with this? It's 0, again 0, again 0. So 0 plus 0 plus 0 is till infinity is 0, right? Yeah, you're right. You're absolutely right about that. So basically the first answer, I would say, the first result, that is S1, comes out to be 0. Wow, that's perfectly fine. Wait a second, let me just yeah. And now let's just do some manipulations here. So S1, we can write that as 1 minus 1, right, plus 1 minus 1 plus 1 minus 1. I'm just using some parentheses up to infinity, obviously. And why I did that? Wait a second. So I'm just gonna do something here like this thing. I'm just gonna do something. So I have to both sides, like you know what, I have to subtract S1 with 1. So basically it's 1 minus this chunk of things, that is 1 minus 1, right, and then plus 1 minus 1 plus 1 minus 1 and plus dot 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 to infinity. And if we are having minus in front of this parenthesis, so that's gonna give us that's gonna just change the signs of inside the parenthesis. So basically it's gonna be 1 minus 1, and this, look, this minus 1 and plus 1 is gonna be minus 1. So this, there it is. And if we talk about this minus 1 and this minus 1, so that's going to be positive 1. So basically it's plus 1. And so for minus 1 plus 1 minus 1 plus 1, and this just, oh wait a second, this is just keeps going up to infinity. It's pretty fine, right? But if you look closely here, so we consider this S1 and still we are having this thing. So basically the right hand side of these two equations are same. So I can replace this infinite sum with S1 here. So it's 1 minus S1 equals S1. And basically adding both sides S1, I'm gonna have 1 equals S1 plus S1, that is 1 equals 2S1, and S1 comes out to be 1 over 2. Like, is that even possible? So I would say, look, you would say it's not possible at all. And yeah, I think you're right. But just take a look at this thing. This is all. We cannot do anything. We can just shift, because infinity plus 1 is also infinity, infinity minus 1 is also infinity. So basically it is true, I would say. Okay, now, okay, so if we just talk about, okay, so basically if we talk about like average of both the results, that is, we got in first we got S1 equals 0, and we got wait a second, and S1 1 over 2 as well. So if we just take, if we consider the average of both the values, so yeah, so basically if we talk about the average, so we cannot consider this result actually, because it's 0. So we have to consider this S1 equals 1 over 2. So yeah, if we talk about the final result, so it's S1 equals 1 minus 1 plus 1 minus 1 plus 1, and this is just keeps going up to infinity, and it evaluates to 1 over 2. I would like to just cover it in a bracket here or a box. Now let's consider S2 here. S2, another sum, I would say. So another sum is 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus dot 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 to infinity. Basically you can say the like alternating sign or with the even terms and with odd terms. Actually you can just think about that. Okay, so again, as I just told you in like right before of this thing, that we can just shift the order, that is adding a term in infinity is also infinity, and subtracting from it as well, so it's also gonna be infinity, right? So we can just shift a place here, that is 1 minus 2 plus 3 minus 4 plus 5, and this is just keeps going up to infinity. Now what we are gonna do is we are gonna adding these two things. So s2 plus s2 is 2s2, and if we add this, so 1 plus 0, right? Okay, and minus 2 plus 1 is minus 1. Okay, minus I'm sorry, plus 3 and minus 2 is plus 1, and this is minus 1 plus 1 minus 1, and again it is just keeps going up to infinity. Just remember, this is the Grandi series, I would say. This is the Grandi series, that is S1, and we have evaluated it to 1 over 2. So from here we can say 2s2 equals 1 over 2, and basically s2 comes out to be 1 over 4. Okay, pretty fine. Yeah, okay. Now the final thing. Okay, let's consider our Ramanujan's paradox. So it was the sum of all natural numbers, right? So let's just say it to s: 1 plus 2 plus 3 plus 4 plus 5 plus dot 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 to infinity. Okay, so this is our s2, I'm sorry, s, and now write s2 just down below s1. So s2 was 1 minus 2 plus 3 minus 4 plus 5 minus 6, I'm sorry. Okay, and this is again keeps going up to infinity. Now so here we are gonna just subtract s minus s2, so the odd terms are gonna be cancelling out here, because 1 minus 1 is 0, 3 minus 3 is 0, 5 minus 5 is also 0, and 2 minus of minus 2, which is 2 plus 2, 4, 4 minus of minus 4, which is 4 plus 4, 8. So basically it is 2, oh I'm sorry, 4 plus 8 plus it's 12 plus 16 plus it keeps going up to infinity. Now s minus s2, we can just plug 4 out of this whole big chunk of things, right? Because it's common in all those terms. So it's 1 plus 2 plus 3 plus 4, and again this is just keeps going up to infinity. And here comes the crazy part, guys. This is the s, sum of natural numbers. Oh my goodness, just take a look at the beauty of it, dude. So basically s minus s2 equals 4s, right? And if we talk about s2, so it comes out to be s minus 4s equals s2. So it's minus 3s equals s2, and s2 we have calculated as 1 over 4 here, as you might see. So if we plug 1 over 4 here, so minus 3s comes out to be 1 over 4. It means s is gonna be this dividing both sides with minus 3, so it's finally comes out to be minus 1 over 12. Oh fuck, like look at this. I know we assumed a lot of things right there, and we literally don't know about this thing, that is the infinity, and maybe it's true, but I would say I believe on the process, but again maybe there are a lot of things which we are which we are not familiar with in mathematics yet. So for that case I would say it's a paradox, it's not true, I would say, because it doesn't make any sense. And you know what, how it is related to Riemann zeta function. Now let's talk about that even, because the subscriber that commented me will not leave my channel because he requested me and I'm not bringing a video for him. I'm sorry for the delay, dude, but yeah, I'm just working for that, and the video will be soon on my channel, don't worry. So yeah, so here it comes. So this is right. So we have a lot of times talked about the Riemann zeta function, and this is the thing that is basically, it is the thing that is in Riemann hypothesis basically, right? Well, you know what, the subscriber, basically I am not that master in complex analysis, and I think complex analysis is quite necessary to understand the Riemann hypothesis. And but still, I'll make a video on that, on Riemann hypothesis. I'm not denying from that, but yeah, maybe I will not explain you in deep, because the prerequisites to understand the Riemann hypothesis is not fulfilled yet by me. So but still, I'll make a video on that, don't worry. So Riemann zeta function, right? it's uh, it's Riemann zeta. Oh, wait a second. Riemann zeta of z equals the sum as n goes from 1 to infinity of 1 over n to the z, right? And how the Ramanujan's paradox is related to the Riemann zeta function? Well, let's replace z with -1 here. So it's Riemann zeta of -1 comes out to be the sum as n goes from 1 to infinity of 1 over n to the -1. And due to the basics of exponents, we can say it's Riemann zeta of -1 comes out to be the sum as n goes from 1 to infinity of n, and this is known as the sum of natural numbers to infinity. And yeah, we just evaluated that, and that was evaluated to -1 over 12. Basically, sum of natural numbers can also be written as the sum as n goes from 1 to infinity of n, and it came out to be -1 over 12. So we have again evaluated for a new Riemann zeta of -1, that is -1 over 12. Well, again, it's not sure, and that's why I haven't talked about this in my videos yet. And yeah, basically it's a theory or a paradox, right? Yeah. So yeah, guys, I would request you to just come up in my next video. I think next video is gonna be on Riemann hypothesis, and we are gonna talk about a lot of things in that video. On basically, we will be diving into Riemann zeta function, and we will be diving into Riemann zeta functional equation and the integral representation of the Riemann zeta function. Yeah, we have proven that, but still, I will just make a video on that which combines all these things concisely, right? Okay, so I think it's fine, guys. And again, guys, if you got to learn something from this video, please make sure to like, subscribe and share. And if you have any kind of doubt throughout this video, so please ask me in the comment section. I'll reply over that as soon as possible. And yeah, goodbye, guys, take care, love you, and stay tuned for the next video, guys, because again, this is quantum mathematics, right? Maybe quantum mathematics doesn't make any sense, the name I'm talking about, but basically, why did I choose quantum mathematics as my YouTube channel's name? Because I love the word quantum, right? We have listened about quantum physics, quantum mechanics, right? And we know that it talks about very tiny particles, like electrons, or maybe if you go further, so it's strings, or quarks, right? So yeah, I know that, but maybe if we can relate this with physics, so we are here to dive into mathematics as small, like as tiny as possible. We have to just dive into the deepest point as we go in quantum physics. So maybe that suits my channel, okay? But it's all right. It's subjective again, and some would like my channel's name and some would not. But still, if you don't like my channel's name, please comment me and suggest me if there any kind of if you have any kind of name which suits my channel. So I think I should leave right now, guys, because it's been 19 minutes and 50 seconds. So goodbye, guys, take care, love you, and again, Just take care because life is unexpected. Actually, death is unexpected. Actually, goodbye, guys. Love you.